So in the last part of this demo, I modified the app to implement a strategy to determine if a request is being throttled. And in the case the request was being throttled, as indicated by the response in the REST endpoint request, I implemented a retry strategy using the HTTP client. But now let's see how this can work if I change the application to use the Microsoft Graph SDK client, because that has logic built into it for implementing the retry strategy when a request has been throttled. So what I'm going to do is we're going to go make an update to our generated HTTP client. So let's go find where that is. There we go, generate authenticated HTTP client. So what I want to do is I want this method. I'm going to replace this method to, instead of calling to creating an HTTP client, it's going to create a Microsoft Graph client. So I'm going to change the name of this to get authenticated Graph client, and it's going to return a Graph service, client. We'll comment out these two lines right here, and instead I will create a var Graph client equals a new Graph service client, and I'll pass in our authentication provider, and then I'll return that back. Now I need to update the application to use our new Graph service client. So let's come back up to the main part of our application. Message detail, there it is. So we don't want to use this graph, this line right here. Instead, I want to use the Graph client. Now, all of these lines right here use the Graph client. So I need to find all of these, and we're going to comment those out. And instead, we're going to replace them with making the exact same kind of request, but using this client response. Now, the collection that's returned by the SDK is in a different format than what the REST API returned. So in this for each loop that enumerated through all of the return messages to the request, I'm going to make a change to this. So instead of it getting graph message in graph messages.items, we're going to do client response dot current page of information that comes back. Now, the next thing I have to do is I need to up or modify my get message detail, because you can see that it's expecting a different kind of data coming in. Recall from the previous demo, I had to write the code to detect when requests were being throttled, and in the case they were throttled, I added code to retry the request after a specified delay. But fortunately, Microsoft Graph's SDK has this logic already baked in. So what I'm going to do is go find this method, and I'm going to change his property that's being passed in to being a Graph service client. Now I'm going to remove all the code within this method and replace it with just a single line that's going to call the graph. So I'm going to take everything inside this method and I'm going to replace it with this single line. And what that's going to do is that's going to use the Microsoft Graph client. And we're going to change the return type here also to be more explicit, so because we can see that we already have that message object, or for this messages object right here. We're going to go change this so that this is going to be referencing the Microsoft Graph This is going to be the Microsoft graph.message object. Now the return types are matching. But you notice we've removed a lot of code, and all that stuff that we had added, we no longer have to worry about that. So all we did was we just changed how we were getting the message data back that you see here. And then we did the exact same thing where we instead of using the HTTP client, we're simply going to go through and make a request and let the Graph SDK do the check to see if things need to be cached or if things need to be delayed. So I'm going to rerun the application. I'll paste in my username and my password, and we'll let the application run. Now the application is going to write multiple log entries to the console. Like we're seeing, we're fetching all those same messages again. So that's the same process we did initially. But what it's then going to do, it's doing the same thing as the previous version did. But the big difference is that it's not going to display the status code return to the response for all the different requests or any of the sleeping log messages, because that's all handled internally by the Microsoft Graph SDK. So we're going to let this fetch all of its messages, all 100 messages, And then we're going to see what it looks like when it goes and responds with getting all 100 of those requests. Here we can see that it's fetching all the emails. When you notice it slow down, that's probably when the Microsoft Graph was issuing its little bit of a delay, or it was handling those responses that it got. So you notice now it's just writing all those responses to the ultimate request that we made, but it's making the process of handling any throttling requests transparent to me as the developer. So in this demo, you saw how I modified the .NET Console application that I previously created to demonstrate two strategies to account for throttling in our application. One of them used the HTTP client object, but it required us to implement the detect, delay, and retry logic myself when the requests were being throttled. The other strategy we employed was using the Microsoft Graph SDK that has included support for handling the exact same scenario.